Has that ever happened to you? Well, today on Tech Garage, we're going to tackle the battery, the charging, and the starting system. And we're going to give you some diagnostic and troubleshooting skills, so when this happens to you, you'll be prepared. Welcome to Tech Garage, presented by Advance Auto Parts. Today we're going to look at the battery system, the charging system, and the starting system. And like always at Tech Garage, we're going to take you inside these systems so you can see how they work. You'll be better prepared when they don't work. But we need to get started with the basics. The first thing we need to look at is three terms. One of them is voltage, one of them is amperage, and the other one is resistance. Now let's start out with voltage. Now voltage is pressure, electromotive force. A little different than amperage. Our battery here is the pressure maker. In the car, it's going to make pressure electrochemically, and that pressure is going to push those electrons in the form of amperage. That's amps. It's electron movement. It's going to go from one side to the other of the circuit, and it's going to help the component work. Now the third one's resistance. The resistance is going to be in the form of some windings. Resistance can be any load. It can be a fuel pump, a wiper motor, a light bulb. Anything is resistance. Now, I got a cool demonstration I can show you that's actually going to illustrate that. Now our pressure here, if I dump this into the container, we're making pressure. And that's what a battery's doing. It's actually making pressure. The more I put in, the higher it goes, the more pressure it's going to have. Batteries have about 12.6 volts fully charged. So this would be our pressure maker. This is our battery. Our pressure maker then, when I pull the plug, the amperage or current is going to flow. When that current flows, it's going to spin this wheel in the form of work. So think about it. The battery, the actual pump right here is going to be our resistance, and then on the other side, it's going to flow through as current. So I'm going to pull the plug and you're going to see it in action. There goes our voltage, moving our actual resistance. Once that moves, it stops, pressure stops, resistance stops. We can look at it on a voltmeter. Now there's three measurements you're going to make: voltage, amperage, and also resistance. The first one's voltage. Now voltage is right here. There can be alternating current voltage or there can be DC voltage. But voltage is good because we like to see voltage drops in some of these systems, like charging and starting systems. That'll tell us if there's any unwanted resistance in the system. Come over here to the omega sign, the horseshoe, that's resistance. Now, components have windings of wires, fuel pumps, starters, solenoids. Everything has some kind of resistance value. We can use that to determine if the component is good or bad. Then we come over to the amperage. Amperage, you saw, was that current flow, the movement of electrons. Once again, there's AC amperage and DC amperage. But if you're measuring amperage, you want to shunt the meter, because what you're going to do is measure amperage in series. We like to do parasitic draws, maybe something sucking the battery down when it's not supposed to. Amperage is a good way to check for that. Voltage is voltage drops, and resistance just on the components. Now that you understand a little bit of the basics, this will help us diagnose our systems when it comes to batteries, charging, and starting systems. And we'll look at the battery now.
Did you know in 1796, Italian scientist Alessandro Volta invented the voltaic pile, the first storage battery? The term volt was created in his honor.
Now you heard the car click earlier. That was probably just a low battery, but we're going to take a look inside of one so you understand how it works. Now our battery here is made up of 6 cells, 2.1 volts. Each cell gives us that 12.6 volts. You can see here there's positive and negative plates. What happens is those positive negative plates, we put some water and sulfuric acid in there, and that makes electrolyte. And between the electrolyte and those plates, you get a chemical reaction, and that chemical reaction makes that pressure we need to start our car. But over time, they're going to deteriorate. I have some here. This is the positive with a separator and a negative. And you can see right in here, if I try to pick this up, it's just falling apart. So what happens is once that starts to deteriorate, you're not going to get the cranking amps you need to start the car. There's a few different types of batteries. This one right here, this is a maintenance battery. You can actually pull the top off, and you can see you can go in there and check some of it. Also top and side post. You can see here I got some top post and I have some side posts. Depending on your configuration, you're going to have to know what you have in your vehicle. Over here, this is a maintenance-free battery. This is actually absorb glass mat technology. And this one here has top post and side post. But there's a few important numbers right here. This CA is cranking amperage, CCA is cold cranking amperage, AH is amp hours, and RC is reserve capacity. Now, an important one here is the CCA. That's cold cranking amps. That's how much cold cranking amps this thing can put out. And what happens is that's determined by the size of the plates. Now, you want to get at least the cold cranking amps your car calls for or more. But if you go into the parts store, they'll tell you exactly what you need.
Here's a Tech Garage Pop quiz. What's the open circuit voltage of a battery that is 75% charged? A, 12.3 volts, B, 10.4 volts, C, 9.6 volts, or D, 8.1 volts. The correct answer is A. A fully charged battery has 12.6 volts. At 75% charge, it has 12.3 volts, and at 50% charge, it will be 12 volts. We'll be right back with more Tech Garage, presented by Advance Auto Parts. Tech Garage is brought to you by Advance Auto Parts. Let's get you back to the garage. ARP, the world leader in fastener technology. Motorcar Parts of America, quality built to last. And by Race Gas, get more out of your engine.
Welcome back to Tech Garage. Well, it's time to dive into our Mustang and see what's going on with this battery. Now, a few of the first tests that we need to run, just look at the open circuit voltage of it. We can do two things. We can have a professional tester here that'll test the whole electrical system, or you can do this right in the garage. We have a voltmeter right here. I got it hooked up to DC volts, and the first thing I'm gonna do is go right across the battery. And you can see we got about 9.53. That's not gonna get the job done. Perhaps it was the battery, but we need to check the whole electrical system. Another test we can do is we can go from the positive and you can move the negative around. This is called a leakage test. If it senses any of that electrolyte, you can see it's starting to produce a voltage. That means that the battery's dirty and needs to be cleaned. One more, I can go from here to the cable and we can crank the car over, and that would be voltage drop. If we had a voltage drop, that means that there's some kind of corrosion between the cable and this one. Now, there's other tests we can also do. There's this hydrometer, and this hydrometer actually is going to go into the electrolyte. We'll suck some up and we'll read the specific gravity of the electrolyte. Right here you can see 1.275 all the way up to 1.30. That's good because there's more sulfuric acid than water. That means the battery is able to put out a charge. There's also a refractometer. Now, refractometer, you just put a drop of that sulfuric acid right there, the electrolyte, close it, look through it, and it'll tell you the specific gravity. That's if you have a maintenance battery, you can get in there. Now, if you determine it's time to replace the battery, first thing you want to do is you want to put one of these memory savers in. This memory saver will keep all the adaptive learn on the engines. Sometimes they have idle learn, shift patterns. It'll keep everything intact. Then you can come over, take the battery out, use these cleaning tools right here. These cleaning tools will actually help you also when it goes to replacing that battery. Now, you can go down to Advanced Auto Parts and pick up any of these tools and do the job yourself. Now, real quickly, there's a couple other tests you can make. Think about this. If I turn on the headlights, if you go ahead and turn on the headlights, you can see the headlights are on real dim, and then you try to crank the car. Go ahead. Yeah, you can see there that the light went dim and we don't have any starting. That means that the battery's dead or you have a mechanical draw, something that's drawing a lot of electricity down. If you were to crank your car and that light stayed bright and nothing happened, that's an open somewhere in the system. So with those tests, you should be confident with the battery. It's time to turn our attention to the starting system.
Here are the tools John suggested and their approximate costs.
Now check this out. We have a starter system completely on a board. Now what's going to happen here, it all starts at the battery. Our battery is going to come up here and it's going to go through this starter relay. Now the starter relay energizes and it sends power over to the bat terminal on the starter itself. That's what causes the car to start. But there's also a control circuit. My other control circuit's coming off of here to the start terminal and it's going through a neutral safety switch. When the car is in park or neutral, that'll allow the current to go through and get to our starter motor and start when we turn the key. I can show it to you in action. Now, if you have a newer car, you may just have a computer located right here, and what that does, you have a radio frequency, an RF module just starting the car with your remote, or just a push button. What's happening there is, it's just giving the computer a signal, it's doing the same thing. It's energizing the start terminal, and it's running. So whether it's old or new, still the same concept. I have a couple starters over here to show you. First one here, this is a field coil starter. Now this is a big starter. What happens here is we energize these field coils. How a starter works is, here's these actual brushes. They feed power into this commutator, and when they feed power into the commutator, it's gonna spin with lines of flux, magnetism. It pushes it around, it pushes it around. When it pushes it around, that pinion is gonna contact this flex plate, or a flywheel if you have a manual transmission, and that's gonna spin around and start the car. Now that's a big starter. This one here, this is a permanent magnet starter. Now what this is smaller in size, and these magnets are fixed right here. So what happens is, we have gear reduction. This is really cool. Take a look at this. If I take this off, you have these little planet gears, and then the armature actually splines right in there. So what's happening is, I don't create such a magnetic field, but watch this. As I turn this, you can see the pinion here is spinning a lot slower than the armature. What is that doing? That's creating torque. We're getting the torque with the smaller package, lightweight package. Now that's a good look at the starting system. Let's see what Brian has in store for us with the email question.
John, we have an email question here from one of our viewers, Terrell in Long Island, New York. Terrell has a 2007 Ford Mustang that he replaced the starter on. Now with the new starter in place, when he cranks the vehicle, he gets a loud grinding noise. What do you think the problem is?
Brian, perfect timing. We're talking starters. Looks like to me, Terrell, you have a starter pinion to flywheel clearance issue, and I can demonstrate it right here for you. What I have is a starter here with elongated holes, and this starter is actually too far away from the flywheel, and you can hear it. In that case, you would remove some shims, and then go ahead and put it back down a little closer to the flywheel. Now, once you do that, move it over, and it sounds a lot better. Now you could also have a pinion too close to the flywheel. So you're cranking and cranking and cranking, release the key and you get that whine, whee! That's gonna go ahead and kick it back. You wanna add some shims, get it away. And you can go down to Advance and pick these shims up. I sure hope that helps.
If you have a question for Tech Garage, email it to techgarage@advance-auto.com and be sure to watch to see if your question makes it on the show. We'll be right back with more Tech Garage presented by Advance Auto Parts.
Welcome back to Tech Garage presented by Advance Auto Parts. Now we got the fundamentals in the bag. Let's go ahead and take a look at some diagnostics. Now there's a lot of diagnostic tests and troubleshooting that you can run on the starter system. And to help us, we have Nelson here from Motor Car Parts of America. Nelson, thanks for joining us. What have you seen out there, or can you show our viewers some tests that they can just perform out in the driveway that may help them with their starter systems?
Sure, John. If we suspect that the starter needs to be replaced on the vehicle, there are a couple of key tests that we want to verify first before we replace that starter. Number one would be to make sure we're getting proper battery voltage to the B+ terminal on the starter solenoid when we're in the crank position. And number two would be to make sure we're getting proper battery voltage to the S terminal of the starter solenoid when we're in the crank position.
All right, well, let's go ahead and do that. If you just take the positive and put it up there, I'll give you a good ground down here.
Okay. Yeah, we want to hook the positive lead to the B+ terminal of the starter solenoid. And then when we go to the crank position, we can actually measure the amount of battery voltage that's available to that B+ terminal.
Well, that one's got about 9 volts. That's good?
That's a little bit low, actually, which might indicate we may have a battery or battery cable problem on this vehicle.
And the second test you mentioned we can do at the start terminal?
Yeah, we'd want to take the positive lead now and place it on the S terminal of the starter solenoid, and again, ground the negative lead of the multimeter.
Okay.
Again, we'd want to go to the crank position.
And that's telling us the voltages at the solenoid is going to go ahead and engage.
Right. If that's too low, then that would indicate we've got a problem in the starter control circuit and not necessarily the starter itself.
Right. Now, what about if they had some resistance problems? That voltage was low. There's a cool test you can do to actually show where the resistance is.
Yes, that's called a voltage drop test, and it's a simple test. What we want to do is we can do a voltage drop test on both the positive and the negative side of the starting circuit. So to do the positive side of the starting circuit, we'll put our positive lead on the B plus terminal again of that solenoid, and we'll put the negative lead on the positive terminal of the battery itself. And when we go to the crank position, we can measure how much voltage drop there is on the positive side of this starting circuit. We'd like to see less than about a 2/10 of a volt drop.
So if there was a big drop, maybe 6/10 or even a volt for that matter, you could have a loose cable somewhere or resistance in the cables.
Exactly, John.
What about the ground side?
Same thing on the ground side. Now we want to move our positive lead to the housing of the starter itself. Make sure we have a good connection there.
Okay.
And now the negative lead will go in the negative terminal of the battery, and this will allow us to determine if the ground portion of the starting circuit has good continuity.
Let's give it a
Again,
shot.
we'd like to see less than about a 1/10 of a volt drop.
Well, that one's in good shape.
Yeah, so that tells us the ground integrity of this starting system is in good shape.
Now, I know they can go get it tested with one of these inductive pickups. They put it around the starter. It's called a starter current draw test. What should a starter for a V8 really draw?
Well, it varies somewhat depending on the vehicle manufacturer. It's best to always check with the vehicle manufacturer to get the exact specifications for that particular vehicle that you're working on. But typically on a V8 engine, it might be somewhere less than about 150 amps.
And if it was drawing a lot, you either have some mechanical resistance that's causing that amperage to go up.
That's right. It could be a problem with the starter itself if it's too high, or even a problem with the engine.
Wow, that was awesome. Thank you so much. You know, you can perform all these tests. It'll tell you exactly what's going on with your starter system. We need to look at the charging system next.
Did you know that prior to the electric starter motor, engines were started by wind-up springs, gunpowder cylinders, and human-powered cranks?
Let's talk charging systems. Now, the alternator's job is to convert mechanical energy into electrical energy, and it does it by belt. The belt here drives from the engine all the way up to the alternator, and that's how it produces its electricity. Now, to do that, it has to produce more electricity than the battery. So we saw earlier, our open circuit voltage was about 12.6 on the battery. Well, when I fire this up, I got about 12.37 here. What happens is it's going to charge more, raise up that pressure, and charge the battery. Now that I have it on, you can see I have about 14 volts, so it raised the pressure there, and that's good. Now to see how an alternator does that, I got some components right here. This is an actual rotor out of an alternator. Now the rotor spins around, it's belt driven, inside of the stator. And then what it does, it actually transfers electricity to the stator, and that's an AC voltage. Then it goes through a rectifying process here, or perhaps a diode trio, and it cuts it out to DC voltage, a ripple current that's going to go over to the battery. What happens is this is a huge electromagnet, and this is pretty cool because I can take this here, and I can power up the rotor, and when I power up the rotor, you can see it's a magnet. Well, think about that for a minute, because if you have these massive amplifiers or generators, the alternator supplies all the current while the car's running. If it needs more, it's going to rob it off the battery. And you can see it in action here. As I spin this, the rotor's spinning around. It's an inducing a voltage into the output here on the AC generator, and you got charging. Now, we need to run some tests on it, so we're going to head to the car next.
We'll be right back with more Tech Garage presented by Advance Auto Parts.
Tech Garage is brought to you by Advance Auto Parts. Let's get you back to the garage. Stage 8, the world's best locking fastener. Motorcar Parts of America, quality built to last. And by B&M Racing and Performance, quality performance products that work.
Welcome back to Tech Garage. Now the fun stuff, up under the hood. First thing we want to check when we're doing any diagnostics, including our alternator, is the belt condition. Make sure the belt condition's good and the tension's proper. Here's a couple tips for you. If the belt's too loose, it'll slip. The alternator won't charge. If a belt's too tight, that puts an excessive amount of stress on the bearings and you may have premature failure of the alternator. Now we could run a few of the tests just like we did with the starting system. The first one I'm going to do is simply go across the battery, positive to positive, negative to negative. And you can see we have 12.24 volts, just like we did on the board. We need to start the car, make sure that the alternator is going to put out more than the battery. If it didn't, we can do some voltage drop tests. Same as the starter. I'm going to take the negative side and go on the negative, and then I'm going to come over to the negative ground of the alternator. Once I clip that on there, if we have more than a 0.5 volt drop, we have a problem. Perhaps the alternator bolts are loose or the mounting hardware, something's not getting the ground completed. We do the same thing with the voltage drop on the positive side. I come over to the positive battery and I come over to the back of the output. Positive to positive, that's a voltage drop. Once again, more than a 0.5 volt, we have some resistance somewhere in the cable. Battery cable could be loose, output terminal could be loose, battery acid could be wicking up the cable, but we need to find that voltage drop so that alternator will charge properly. Now, we took our EXP 1200 here, we hooked it up, we went through the system test, and we have our results right over here I can show you. I got 2 sets of results here. First of all, this one's no voltage. Tells you here, check the charging system problems, belts, grounds, terminals, whatever it may be. But you notice we only have 11.67 volts. So at 11.67 volts, it's not putting more pressure than the alternator. So when that happens, you see there's no voltage here. Now on our good one, perfect. 14.8 volts, got a ripple pattern. That's cutting that AC to DC and it's going back to the battery. Alternators only use or put out what a battery needs. So if it needs more, it'll charge more. Well, we went through charging systems, starting systems, and the battery. We're about out of time, so you should be confident now to go out there to your garage and test any one of these systems. The tests were pretty simple. Thanks for watching, and we'll see you next week on Tech Garage presented by Advanced Auto Parts.